Hello everyone, myself Harsh Kumar, student of BSc Chemistry Honours second year. This is my presentation video on unit thermodynamics. In this video, we will talk about basic terms used in the unit thermodynamics. So first term is system. A system is a defined space under observation which contains energy and matter. Second is surrounding. The surrounding is anything surrounding around the system which interacts with it. When we add system plus surrounding, we get the universe. System can be divided into two types on the basis of phase: homogeneous system and heterogeneous system. Homogeneous system is in which only one phase is present. In an heterogeneous system, more than one phase are present. System can be further divided into three types: open, closed, and isolated system. In an open system, mass exchange and energy exchange both are possible. In closed system, only energy exchange is possible, whereas mass exchange is not possible. In an isolated system, both energy and mass exchange are not possible. Then we have walls. A wall is a boundary that separates the system from the surrounding. There are different types of walls. Wall can be flexible or movable, or it can be rigid also. It can transfer or conduct heat, which is known as diathermic wall, or it may be insulating wall, which is also known as adiabatic wall. Then there are few properties of system. Here we will consider about only two properties of system, which are intensive and extensive. Intensive property of a system are those which are independent of mass, such as density, vapor pressure, temperature, melting point, boiling point, or etc. Second are extensive properties which are dependent of mass. Example: internal energy, entropy, enthalpy, Gibbs free energy, moles, volume, mass, etc. Extensive property are additive in nature, whereas intensive properties are non-additive in nature. It means that we can simply add two masses to get the resultant mass. But in case of melting point or boiling point, which are intensive property, we cannot simply add to get the melting or boiling point of the resultant solution. When we divide a extensive property by extensive property, the property which we get is intensive in nature. And when an extensive property is divided by mass, it results in the intensive property of the resultant. Next we have thermodynamic functions. There are two types of thermodynamic functions. One is state function, second is path function. State functions are independent of the path taken. They depend only on the initial and the final state of the system. State functions include internal energy, Gibbs free energy, enthalpy, entropy. In a cyclic process, delta state function is 0. Now moving towards path function. Path functions are those functions which depends on path taken. It includes heat and work. Moving towards heat, which is represented by Q. Heat is disordered form of energy flowing from high temperature to low temperature. Sign conventions for heat in chemistry are as follow. Heat given by system or heat released by system is taken as negative. Heat given to system or heat absorbed by system is taken as positive. Calculations of heat. Heat is divided into two categories. One is latent heat represented by QL, and second is sensible heat represented by QS. Latent heat is heat used to change the phase or state only at constant temperature. Latent heat is calculated with the given formula as QL is equal to M into L. where m represents mass and L is latent heat of fusion or vaporization. In terms of moles, the latent heat can be calculated as QL is equal to N into L, where N represents number of moles and L represents latent heat of fusion or vaporization. Second, sensible heat. Heat used to change temperature of system without changing its state is known as sensible heat. It can be calculated with the formula Qs is equal to C delta T, where C represents heat capacity in the unit joule per Kelvin and delta T represents temperature or change in temperature in Kelvin. Or it can be calculated with Qs is equal to mc delta T, where m represents mass in the gram, small c represents specific heat capacity in the unit joule per gram per Kelvin, and delta T represents change in temperature. In terms of moles, sensible heat can be calculated with the formula Qs is equal to Ncm delta T, where N represents number of moles, Cm represents molar heat capacity with the unit joule per mole per Kelvin, and delta T represents temperature change in Kelvin. Now let's go through the terms we just mentioned. The first one is heat capacity. It is the heat required to raise temperature by 1 Kelvin or 1 degree Celsius. Second is specific heat capacity. It is the heat required to raise temperature of system of 1 gram of substance by 1 degree Celsius or 1 Kelvin. Heat capacity by mass is results into specific heat capacity. Here, heat capacity by mass, as we studied earlier, when we divide extensive property by intensive property or any extensive property, the resultant is intensive property. So, specific heat capacity is an intensive property. This formula can be simplified as capital C upon m is equal to small c. Molar heat capacity is equal to specific heat capacity into molar mass. Moving towards our next term, which is work. Work is ordered form of energy. Sign convention for work. Work done by the system is taken as negative work or expansion. Work done on the system is taken as positive as in case of compression. In chemistry, work done is equal to negative of P external plus delta V. Here negative sign is due to IUPAC convention and P external represents external pressure and delta V represents change in volume, which can also be written as final volume minus initial volume. Magnitude of work done can be calculated by area under PV curve or pressure volume graph curve. Unit of work or heat are calorie, joule, liter per atmosphere. 1 calorie is equal to 4.2 joule and 1 liter atmosphere is equals 101.3 joule or 100 joule. Thanks everyone. That's all for today.